Picture this. Late autumn, 1918. The guns have fallen silent, but the ground still looks like the moon. From the Somme to Verdun, engineers stare at the same unforgiving lesson. Wheels alone are not enough. Trucks bog down. Tanks grind forward and then break. Armies need a way to move men and guns through mud, snow, and shattered earth without waiting on the weather or the road. The solution does not arrive as a single invention. It emerges from a hybrid idea that seems almost contradictory. Keep the steering ease of wheels in front. Add the traction of tracks in back. A half-and-half machine that might, just might, combine the best traits of both. A French engineer named Sd.Kfz was among the first to make it real. During the war, he worked for the Russian Tsar, trying to keep the imperial cars moving through deep snow and rough forests. His fix was clever and practical. Replace the rear wheels with a flexible rubber belt track driven by sprockets. Keep the front wheels for steering. Suddenly, a limousine could glide over drifts that would stop a truck cold. After the war, Citroën acquired the patents and launched the Sd.Kfz system. Those half-track cars went on audacious expeditions across the Sahara and into Central Asia, proving the concept in the harshest terrain. At first, it was not about war. It was about mobility when nature said no. Then the 1920s and the early 1930s arrived with hard questions. Tanks were slow and temperamental. Some British heavy models crawled at walking pace. Trucks were quick on pavement, but hopeless off-road. Infantry still marched. That mismatch threatened to split armies apart. Armored units could break through, only to pause for the riflemen to catch up. Across Europe and in the United States, designers began tinkering. In Germany, forbidden by treaty to build tanks, engineers explored unusual chassis under the cover of agricultural machines. In the Soviet Union, planners tried half-track prime movers to haul guns and supplies across vast distances. In America, the Rock Island Arsenal and private firms strapped tracks to trucks and drove them into ditches to see what survived. The appeal of the half-track was the engineering compromise. Not perfect, but balanced. You could get most of a tank's off-road traction with most of a truck's speed and simplicity. Front wheels gave intuitive steering without the complex brake and clutch systems used by fully tracked vehicles. Rear tracks spread weight over soft ground and kept the vehicle moving in mud, sand, or snow. Because the tracks did not have to steer, the whole mechanism could be lighter, cheaper, and easier to maintain than a tank. Early American trials like the Cunningham T1 looked ungainly, but they crossed trenches that swallowed ordinary trucks. By the mid-1930s, the world was rearming. Japan pushed into China with mechanized columns. The Spanish Civil War showed that modern operations demanded infantry who could ride forward protected and arrive ready to fight. Half-tracks stopped being curiosities. They were becoming necessities. The Americans approached the problem with mass production in mind. White Motor Company in Cleveland, Autocar in Pennsylvania, and Diamond T focused on designs that could be built by the thousands on assembly lines. The result was a family of vehicles, most notably the M2 and M3 half-tracks. They looked plain, tall, boxy, purposeful. Under the skin, they hid practical, well-thought-out engineering. Under the hood sat the Hercules JXD inline six-cylinder gasoline engine. Big displacement. Modest power by modern standards. Roughly 147 horsepower at a few thousand revolutions per minute. The important part was reliability and familiarity. Civilian truck mechanics could service it with tools they already owned. The engine lived up front, like a normal truck, so cooling and maintenance were straightforward. On the road, an M3 could reach roughly 45 miles per hour. Off-road, speeds dropped to the 20s, depending on ground conditions. That was fast enough to keep up with tank columns and quick enough to reposition under fire. A 4-speed manual gearbox, mated to a 2-speed transfer case, gave 8 forward ratios and 2 reverse. That broad range let a careful driver crawl up steep grades in low range or cruise in high range without over-revving the engine. Power split forward to the steering axle and back to the track drive. Steering was a blend of wheel angle and, when needed, gentle braking on the inside track to tighten the turn. It took practice, but a skilled driver could swing an M3 surprisingly tightly without tearing up the ground. The track system showed American pragmatism. Firestone developed rubber band-style tracks with steel cables embedded inside and rubber blocks on the outside for grip. They ran quieter than steel links. They wore better on pavement. And if a section failed, crews could replace blocks instead of an entire track run. The suspension used compact spring units that soaked up impacts enough to keep the vehicle moving. It was not a luxury ride. Soldiers joked that the back was a cement mixer with seats, but the design spread the vehicle's weight over a large footprint. Ground pressure sat in the neighborhood of 10 pounds per square inch. A comparable truck could press 4 times that onto the mud. That difference meant the truck sank while the half-track clawed forward. Then came production. After the United States entered the war, the output curves went almost vertical. By mid-1942, factories were building hundreds per month. By 1943, over 1,000 per month. By war's end, more than 40,000 half-tracks in multiple variants had rolled off American lines. They were not the most refined machines. They did not need to be. They were good, plentiful, and adaptable. German designers took another path. Pursuit of technical excellence, even if it meant complexity. The key German troop carrier was the Sonderkraftfahrzeug 251, often called the Hanomag, after one of its manufacturers. It was the backbone of the Panzergrenadier units, the armored infantry who rode with tanks. The engine was a Maybach inline 6, designed for tracked vehicles, tuned for strong torque at low engine speeds. Power output was around 100 horsepower, but the chassis, gearing, and suspension made excellent use of it. On roads, the Hanomag could run past 50 kilometers per hour. Cross-country speeds were similar to its American counterpart. The gearbox was a pre-selector type with many ratios. The driver chose the next gear. Then a clutch tap triggered the shift through a vacuum-assisted system. When maintained perfectly, shifts were smooth and quick. When maintenance slipped, the system demanded skilled mechanics and precise parts. That was the German story in a nutshell. Brilliant when everything aligned. Demanding when conditions were harsh. The German track was made of steel links pinned together, much like a tank, but narrower. Tough, long-lasting, and loud. Steel links excelled in deep mud and extreme cold, where early rubber compounds could crack. The suspension used overlapping road wheels arranged in a staggered pattern. Seen from behind, they interleaved like the teeth of a zipper. That spread the load, lowered ground pressure, and delivered a remarkably smooth ride over rough ground. Crews praised it. Mechanics cursed it. Mud and ice packed between the close-set wheels and froze solid in winter. Replacing an inner wheel meant stripping off outer wheels first. Daily maintenance could devour hours. Manufacturing reflected these choices. Building a Hanomag demanded far more skilled labor hours than building an American M3. Germany produced roughly 15,000 of the troop-carrying variants during the war. Impressive under bombardment and blockade, but overshadowed by the American quantities. Two philosophies, cast in steel and rubber. Quality versus quantity. Half-tracks began as carriers and prime movers. Carry a squad. tow a gun, deliver ammunition. But war forces improvisation. Someone asks the essential question: why not mount the gun directly on the vehicle and keep the wheels, or rather, tracks, under it? Now the artillery no longer waits for a truck. It arrives, fires, and moves before the enemy can answer. Easier said than done. Firing a cannon puts brutal stress into the chassis. Recoil tries to shove the vehicle backward. If the gun is bolted to the body without reinforcement, the frame twists, welds crack, and cargo beds buckle. American engineers solved it step by step. On the M3 gun motor carriage, they mounted the venerable French 75mm gun on a pedestal tied directly into the frame rails. They added recoil cylinders that let the barrel slide back and soak up energy. The crew deployed stabilizer legs and spades that bit into the ground before firing. The result was mobile firepower that could ambush, shoot, and scoot. Scale that up, and the challenges grow. The M12 gun motor carriage carried a 155mm howitzer on a lengthened half-track chassis. Before firing, the crew dropped a massive rear spade into the earth like an anchor. Without it, each shot shoved the 20-plus-ton vehicle backward. Ammunition was a new problem. Big shells eat space and weight. The M12 could carry only a handful of rounds on board and relied on a companion carrier to bring more. German designers took a different tack on many variants. The Sonderkraftfahrzeug 251/9 mounted a short-barreled 75mm gun for direct fire support. It was an assault gun for close fights, enough punch to smash a bunker or a wall with limited traverse to keep the mounting simple and strong. It was not meant for lobbing shells over hills. It was meant to roll with infantry and put high-explosive rounds on visible targets. Ammunition lived in armored bins along the hull sides. Space was tight. Everything was a trade-off between firepower, protection, and weight. Anti-aircraft versions pushed the platform even further. The American M16 multiple-gun motor carriage mounted 4 50-caliber machine guns in a powered turret. A rolling wall of tracers, 2,400 rounds per minute at full rate across all barrels. It was devastating to low-flying aircraft and terrifying to infantry. But the turret was heavy and sat high. Engineers balanced it with careful weight distribution and minor changes to the suspension. The interior became a magazine of ammunition boxes. Run the guns flat out, and you burned hundreds of pounds of ammunition in minutes. Crews learned discipline, short bursts, aim, move. Then there were tank destroyers. In 1941 and 1942, both sides met unexpected armor. Heavier German tanks. Rugged Soviet designs like the T-34. Building new tanks took time. Mounting anti-tank guns on existing half-tracks could be done in months. The American M3 gun motor carriage was the quick answer. A 75mm gun on a simple mount. Thin armor. Open top. Exposed crew. It was deadly from ambush and vulnerable in the open. At Kasserine Pass, American units learned fast. Use cover. Fire from hull-down positions. Relocate. Do not duel head-on. Reports stressed a simple rule. These vehicles could dish out damage, but they could not take it. Germany pursued its own solutions. The Sonderkraftfahrzeug 251/22 mounted the PAK 4075mm anti-tank gun. It could penetrate thick armor at long range, but the chassis was at its limits. Ammunition capacity was small. Weight grew. Stability suffered on uneven ground. Crews used the first shot advantage and then moved before enemy guns answered. The Soviet experience added another dimension. The Red Army used domestic half-tracks, like the ZIS-42, to tow guns through mud and snow. They also received thousands of American half-tracks through Lend-Lease. Soviet crews appreciated the cross-country ability and the relative comfort compared to marching. Some units mounted heavy DSHK machine guns for anti-air and fire support. The machines fit a doctrine of deep movement, where speed and endurance mattered more than perfect engineering polish. Half-tracks were more than metal and engines. They were workplaces. Open-topped variants left crews in the wind, the dust, and the rain. In winter, faces froze. In summer, dust-caked lungs and eyes. Armor was thin. Sides kept out fragments and rifle rounds, but heavy machine guns and guns with larger calibers could tear through. Yet, compared to riding on a truck bed under fire, a half-track felt like safety. Compared to slogging 20 miles on foot, it felt like a gift. Maintenance defined the routine. American rubber tracks ran quietly and lasted well on roads, but they required inspection for cuts and damaged blocks. German steel links demanded constant tensioning and pin inspections. The interleaved German wheels rode smoothly, but cleaning packed mud in freezing weather was a daily battle. Fuel systems had to survive cold starts. Mechanics improvised heaters, canvas covers, and tricks learned the hard way. Logistics kept the whole system alive. Spare engines, gearboxes, tracks, and tires traveled in a vast supply web that dwarfed the machines themselves. Doctrine matured alongside hardware. In American formations, half-tracks carried armored infantry who fought, dismounted. The vehicle brought them into the fight and provided suppressive fire with a ring-mounted machine gun. In German Panzer Grenadier units, the troop carriers were integral to combined arms tactics, maneuvering with tanks, engineers, and artillery. Communications gear improved, turning the vehicles into mobile nodes in a network of fire and movement. Radios mattered as much as armor. Half-tracks also served as command posts, ambulances, recovery vehicles, and prime movers for anti-aircraft and field guns. Flexibility made them indispensable. Standardization made them buildable at scale. The American approach prioritized common components across multiple variants. The German approach prioritized performance tailored to specific roles. Both worked in their own ways. Both reflected industrial realities. By the end of the war, the hybrid had proven itself. It was not the last word. It was a bridge. Post-war, fully tracked armored personnel carriers took over frontline roles. Better suspensions and powertrains made full tracks more reliable. At the same time, advances in tires, drive trains, and independent suspension resurrected pure-wheeled designs. 8-wheel vehicles with central tire inflation and high ground clearance could go places that used to demand tracks. The hybrid had carried armies through a brutal era. Now technology moved on, but the half-track did not vanish overnight. Israel ran American M3 and M5 variants for decades, upgrading engines and armoring. France used them in Indochina and Algeria. Many smaller nations kept them in service as gun carriers, patrol vehicles, or training platforms. Photographs from the 1950s and 1960s show them still rolling, still hauling, still doing the jobs they had always done. Why did the hybrid work? Because it addressed a core truth of warfare. Movement is survival. Firepower matters. Protection matters. But without mobility, both fade. The half-track balanced traction and speed well enough, and at the right time in history, to transform how infantry moved alongside armor. It carried squads across ground that broke trucks. It hauled guns out of quagmires. It made anti-aircraft guns mobile, made artillery quicker to emplace, and gave commanders a flexible tool they could adapt to nearly any task. Look back to the beginning. Kfz's snow belt on an imperial car, Citroën's desert caravans. experimental chassis at Rock Island and Berlin. Then the uniforms and paint and dust of war. American M2 and M3 half-tracks roaring down a French road. German Hanemags sliding through Polish mud. Soviet drivers coaxing ZIS prime movers through snowdrifts. Crews swearing at seized bolts, then smiling as the vehicle pulls free of the mud where a truck would drown. Mechanics teaching drivers to use the brakes to swing tight, to feather the throttle, to feel for traction through the seat. Engineers wrestled with physics, ground pressure, weight distribution, torque curves, heat management, shock loads from recoil. Every nut and weld represented a choice: rubber or steel, ease of maintenance or ultimate performance, speed or protection, ammunition or fuel. And behind those choices lay factories, supply lines, training programs, and doctrine. Half-tracks carried more than soldiers and guns. They carried an idea forward, that the answer to a complex problem might be a compromise, executed well and produced at scale. Not a perfect machine, but the right machine for a moment, when armies needed to cross a battlefield no one had ever seen before. When you hear the clatter of tracks and the thrum of an inline six, imagine the design trade-offs hidden in that sound. Imagine the crews bracing for a recoil shock as the stabilizer bites into the dirt. Imagine the driver grinning as the front wheels bite and the rear tracks churn, pulling the vehicle out of a rutted field where trucks gave up. Tank, truck, artillery, all at once, and good enough to change the way wars were fought.